Hey guys, so where are we at here? Tuesday morning. I'm gonna go over this moles to grams, grams to moles worksheet that's due today at 10 a.m. I think. Let's see. What did I say here? Due at 10 a.m. Right. So, um, yeah. So I'm gonna go through each one of these, and then I'm going to um, show you how to convert grams to moles or moles to grams, grams to moles to do a molarity problem. Like this worksheet here, this one here. And due tomorrow is going to be 8, 9, and 10. I might throw another one in there. So let's go back to this one here. Actually, it's right here. Okay, so I already took a picture of this here, so I'm just going to leave this up. All right. So how many moles are in 22 grams of argon? So actually, let me get up my reference tables, and there we go. All right. So, and I'm pretty sure I can. What is this thing? What does that do? There we go. Hey, look at that. All right. So argon. Mass number 39.948, also known as 40, and that's 40 grams per mole. So we go back here. So argon has 40 grams in 1 mole. So that's the first half of the proportion. We want to know how many moles are in 22 grams. So then basically you're just cross multiplying. I got to get a calculator. I keep using my phone. This is ridiculous. So it's 40x equals 22 divide by 40, divide by 40. So 22 divided by 40, and we get 0.55 moles. There's the answer to number 1. Okay, number 2, how many grams are in 88.1 moles of magnesium? So magnesium is over here. 24 grams per mole. Go back here. So we got 24 grams in 1 mole. We want to know how many grams are in 88.1 moles, right? So again, grams on top, moles on the bottom. Grams on top, this would be grams, moles on the bottom. Grams on top, moles on the bottom. Grams on top, moles on the bottom. How many grams? X goes there. These are easier because you just multiply 24, this is 24, times 88.1. 24 times 88.1 equals 2,104.4 grams, which makes sense because if 1 mole is 24 grams and you have 88 moles, that's an enormous amount. Okay. All right. Now we're doing number 3. How many grams are in 0.02 moles of beryllium iodide, BeI2? So now we go here. So now this is a compound. So Be is 9 grams per mole, right? So Be, so if we're doing BeI2, Be is 9 grams per mole, okay, or 9 grams in 1 mole. So now iodine, come over here. Iodine is 127 grams per mole, right? We're going to round that, 127. And on the regents, you can also round to whole numbers, but that's not really relevant right now. So back to this. So what did we just say? 127. All right. So we have 2 I's, 127 and 127 grams per mole, right? Grams per mole, grams per mole. So what we do is we add all 3 numbers up. So 127 plus 127 plus 9 gives us the gram formula mass of BeI2, or sometimes called the molar mass. And what does that tell us? How many grams of this compound are in 1 mole? Once we know that proportion, right, this side, the other side is where we're going to solve. So 127 plus 127 plus 9 equals 263 grams in 1 mole of beryllium iodide. Question says, how many grams, X grams, in 0.02 moles, right? Grams over mole, grams over mole. So 263 times 0.02, and X equals 5.26 grams. So that's the answer to number 3, 5.26 grams. All right, so there's 1, 2, and 3. Back to this one. Okay, let's do 4, 5, 6. Well, we'll just do 4, 5, I guess, for now. All right, 4 and 5. All right, so number 4, here we go. How many moles are in 68 grams of copper 2 hydroxide, CuOH2? All right, this one's a little tricky because you got 2 H's and 2 O's, right? So that 2 is for both of them. So you know what? Maybe I'll just label it here very small. So copper, then we have 2 oxygens and 2 hydrogens. So I'm going to take the mass of oxygen and multiply it by 2, mass of hydrogen multiplied by 2. All right, so I'm not going to show each number. Maybe I will. All right, we'll see. Here we go. All right, so, all right, back to this. So, copper is 63.546. So 63.5, that's 64 grams per mole. So copper is 64 grams per mole. Oxygen, you guys probably know, or maybe not, but I feel like you probably do. Oxygen is 15.999, right? So 16 grams per mole, and that's 1 oxygen. So if I have 2 oxygens, 16 and 16 is 32 grams because there's 2 oxygens, 16 each. Okay. Hydrogen is 1, so that's 2 grams, right? So I'll just show you that. But hydrogen has a mass of 1 up here, mass of 1, right? Okay. So now we add 64 plus 32 plus 2. So 32 and 2 is 34. 34 and 64 is 98, right? 34 and 64, 98, right? So this whole thing here is 98 grams per mole. That's the gram form of the mass of CuOH2. So 98 grams in 1 mole equals, how many moles is what we're looking for. So X moles in 68 grams, right? So now we cross multiply and divide. 98X equals 68. Divide by 98. Divide by 98. X equals 68 divided by 98. And we get 0.694 moles. So that's the answer to number 4. All right. Let me just erase this so it's not in the way. Okay. All right. Here, I can make that smaller. 98, 98. All right. So number 5, how many grams are in 3.3 moles of potassium sulfide? Same thing. Look up the K and the S, add them up. All right. So K is 39. So 39 and 39 is 78 grams. Because it's 39 plus 39, which is 78 grams for both Ks, 78. Sulfur is 32 grams, but I'll show you. Sulfur is 32 grams. There we go. So 78 plus 32, what's that, 100? No, 110. 110 grams per mole. All right. 110 grams per mole. That's the gram form of the mass of K2S, 32 plus 78. All right. So if we know there's 110 grams in 1 mole, then how many grams, right? X grams and 3.3 moles. So X is 330 grams. All right. I don't think I did that right. No, because that would be 100, not 110. Sorry, going too quick there. 363. 363. 3.3 times 110. 363. All right, so that's number 5. All right, back to this. 6, 7, 8. I can squeeze all these in here. 6, 7, 8. Here we go. All right, so 6. All right, how many moles are in 1.2 times 10? So really, that just means 1200, right? 1,200, because you move a 3 to the right. All right, how many moles are in 1,000 grams of ammonia? So again, we're looking up the masses here. Nitrogen is 14 grams. Each hydrogen is 1. That's 3 grams. So that's 17 grams per mole. I'm going quicker because you've been watching me do that now, hopefully. So N is 14. So that's 14. And each hydrogen is 1. So that's 3. Right? So there we go. So 17 grams per mole. All right. So if we know 17 grams are in 1 mole, we want to know how many moles, right? Always know what you're solving for. How many moles, X moles, in 1,200 grams? Cross multiply, you get 17X equals 1,200. Divide by 17, divide by 17. X equals 1,200 divided by 17. We get 70.59 moles. So there's number 6, which makes sense because that 1,200 is way bigger than 17. So if 1 is in 17, that's going to be a significant increase in moles, which means number of particles, right? Remember, 1 mole is 6.022 times 10 to the 23rd particles. So if you have way more grams, right, a larger mass, you're going to have much more particles. So 70.59 moles. Okay, number 7. How many grams are in 2.3 times 10 to the negative 4 moles of calcium phosphate? So 2.3 times 10 to the negative 4 really means 0.00023. That's what that is, because you go 1, right? If you're here, 1, 2, 3, 4. All right, calcium phosphate. This is tougher because you can make mistakes with math here, but you have to take 40 grams times 3. Then you take phosphorus, which is 31 times 2. And then you take oxygen, which is 16, and that's times 8. Because you have 8 oxygens. 2 times 4 is 8. There's 8 oxygens. Here's my oxygen. Here's my phosphorus. Here's my calcium. And you have 2 phosphorus and 3 calcium, right? So calcium is 40 grams per mole. Phosphorus is 31 grams per mole, and oxygen 16. So that's what I'm doing. 16 times 8, 31 times 2, and 40 times 3. So 40 times 3 is 120, plus 31 times 2, which is 62, plus 16 times 8, which is 128. Right? So this is 128, this is 62, this is 120. Add those up, and we get 128 plus 62 plus 120, and we get 310 grams per mole. That is the gram formula mass or molar mass of calcium phosphate. Regents likes to do this because they want you to screw up with the subscripts, so don't let them win. All right, so that's 310. Now we set our proportion up. 310 grams per 1 mole equals... how many grams are in? All right, so X grams, and this number here, 0.00023, goes on the bottom. Okay, so now you just cross multiply. 310 times 0.123023, and we get 0.0713 grams, which makes sense because if 1 mole is 310 and this is really small number of moles, then you're going to have a really small number of grams. I didn't give you any sig fig rules here, which is fine. So, here I kept 4. This one I kept 3. This is more practicing. Can you solve it, right? Do you understand how to set it up and solve? Make sure you always show work. Always label units. So you always got to show your proportion. Always label units, box, circle, answers. All right. Let's see here. Number 8. How many moles are in 3.4 times 10 to the negative 7 grams of silicon dioxide? All right. So remember this number here. And if you have a scientific calculator, just leave it in powers of 10. So on your calculator, you would do 3.4 times, nope. It would be E. Negative 7, but it's hard for me to do this here recording on the screen, but the real number, if you wanted to, would be 0.6 zeros, 1, 2, 3, 4, 5, 6, 3, 4, because if the decimal is here, it's 1, 2, 3, 4, 5, 6, 7 grams. All right, SiO2, so 2 oxygen, 16 plus 16 is 32 grams per mole. And then silicon, I believe, is 24. Oh, 28. 24 is magnesium. 28 grams. So 32 and 28 is 60 grams per mole, right? 32 and 28 adds up to 60 grams per mole. So 60 grams in 1 mole equals this number here. I'm just going to write the power of 10 here. 3.4 times 10 to the negative 7 grams over x moles, right? How many moles? 60x equals 3.4 times 10 to the negative 7. Divide by 60, divide by 60. This number is going to be very small. All right, divide by 60, and we get 5.67 times 10 to the negative 9th grams. And if you were to write that out, it would be 0.80s. 1, 2, 3, 4, 5, 6, 7, 8, 5, 6, 7 grams. Probably could have changed that number. I could have, I'll be honest, I stole this from somebody who already made this worksheet up because I figured, why reinvent the wheel? I've made a million of these things over the years. Not a million, but I figured just borrow somebody. So I should have changed that number though. All right, so there's that. Okay, I'm going to stop this recording, post it, and then I'm going to put another recording showing a couple problems of how to use this math with the molarity. And then you can use these 2 videos to help you do numbers 8, 9, and 10 on that molarity worksheet, which is due tomorrow, and I'll give you probably a couple more too.